Okay, this is the video for your review. We're going to do this in a few parts, though. This is a little longer, and so I thought it would maybe help you all to have it in chunks, and it would definitely help me on the recording end. So, starting with number one. Okay, if n represents any integer, then an expression representing all coterminal angles with 100 is 100, or sorry, with 120 is 120 plus 360 n. Okay. Then number two, when we are looking at negative 270 degrees, the negative implies that it's going counterclockwise. And we know that 0 is at the x-axis, so our graph is going to be the graph of number A. It starts here and it goes to the positive y. The least positive coterminal angle can be found by taking negative 270 and adding 360. So that gives me 90 degrees there. And then to find the greatest negative, I'm going to take negative 270 and subtract 360. And so that will give me negative 630 degrees for that part. Okay. So when your angle is in standard position, the terminal side does not lie on a quadrant. And that's because the terminal side is here at y, at the positive y-axis, and so that is not a quadrant. Okay, number three. We know that the angles in a triangle add up to 180, so my equation will be 2x plus 4 plus x plus 32 plus 1/4 x plus 53 equals 180. Okay. So that's going to give me 13/4 x plus 89 equals 180. And so 13/4 x equals 91, which makes x 28. Okay. So then when we want to find the measure of angle A, we're going to say 2 times 28 plus 4. So that'll give me 60 degrees. When we want to find the measure of angle B, we're going to say 28 plus 32. So 32 that is, not 36. So that gives me 60 degrees. And that leaves the other angle also being 60 degrees without even substituting it in, because the angles have to add to 180. Okay, number 4, when we're finding the cosecant of negative 450 degrees, that's going to be the same thing as the cosecant of negative 90 degrees. When I add 360 to negative 450, that will give me an angle that I am more comfortable in dealing with on our circle. And so negative 90 degrees would be down here. And that ordered pair is 0, negative 1. And so cosecant is going to be the reciprocal of y. If I take the reciprocal of negative 1, I still end up with negative 1. Then for number 5, we have 3 times the cotangent of 90. So the cotangent of 90 would be 0. And that's because at 90 degrees here, my ordered pair is 0, 1. And cotangent is x over y. Okay, and then plus 7 times the sine of 270. Well, here's 270. That ordered pair is 0, negative 1. My sine value is the y, so that's 7 times negative 1. 3 times 0 plus 7 times negative 1 is negative 7. Then for number 6, cosine is 1 over secant. And so that means secant is 1 over cosine. Those are reciprocal identities. And if you multiply cosine times secant, then that should give you 1, since those are reciprocals of each other. Okay, then for number 7, we know A is 3 and B is 4. And so that leaves C to be 5 because that's a Pythagorean triple, 3, 4, 5. If you don't know your triples, then use the Pythagorean theorem where C is the hypotenuse. Okay. So the length of side C is 5. Sine is opposite over hypotenuse. If we're going from angle B, the opposite side is 4. The hypotenuse is 5. Cosine of B would be 3 over 5 because it's adjacent over hypotenuse. And then tangent is opposite over adjacent, so that would be 4 over 3. And then secant is the reciprocal of cosine, so that's going to be 5/3. Cosecant is the reciprocal of sine, so that's going to be 5/4. And then cotangent is the reciprocal of tangent, so that's going to be 3/4. Okay, moving on to number 8. The value of the sine of 240. So let's think about where 240 degrees would be. This is 180. This is 270. So we're looking at 240 being here in quadrant 3. Okay. And we know all students take calculus. So in quadrant 3, only tangent is positive, so sine is going to be negative. And that's because it's in quadrant 3. Okay, 240 would be 60 degrees away from 180, so the exact value will match up with 60 degrees. And at 60 degrees, your ordered pair is 1/2 radical 3 over 2, but we're in quadrant 3 where everything is negative. Okay, so my sine value is the y coordinate, so it's going to be negative radical 3 over 2. And you can use your unit circle on the test if you want to be able to get those ordered pairs if you don't have those down. Okay, on number 9, when you're finding the reference angle, first of all, you need to find a coterminal angle. So I'm going to take 757 and subtract 360 twice. And that will give me 37 degrees. So I don't have to apply any of my reference angle formulas because once I found a coterminal angle, then it gave me a quadrant 1 angle. So that is 37 degrees. I just subtracted 360 twice because once I subtract once, I'm still more than 360, so I subtracted again to get it down to something between 0 and 360. Okay, number 10, when we use our calculator here, I'm going to type this in. I need to make sure that I am in degree mode. Try to make this a little bigger so you all can see it. There we go. Okay, so mode is in degrees, so we're good there. Clear this out, and then we'll start typing in. We have the sine of 134. Remember, your degree symbol is in the degree menu, so it's second apse. And then 18 minutes is in that same place, so second apse, number 2 is our minute symbol. And then cosine of 45 degrees, 42 minutes. And plus cosine 134 degrees, 18 minutes. And then sine 45 degrees, 42 minutes. And that gives me 0. Okay, number 11. So we have a plateau that is 66.2 meters. The angle of elevation to the top is 39.5 degrees, and we want to know how far we are from the base of the plateau. So that's our x. Okay. So once I have the diagram drawn, I'm going to look at the angle that I'm given. The 66.2 is across from that, so that's my opposite. The side that we want to find is x, that's adjacent. So if we're thinking about SOHCAHTOA, this is my setup. I have O and A, so I'm going to use tangent. So I'm going to say the tangent of my angle is equal to the opposite. The opposite is 66.2 over the adjacent. The adjacent is x. So when I go to solve, I'm going to multiply both sides by x. So now I have x tangent of 39.5 equals 66.2. And then I'll divide by the tangent of 39.5. Your calculator should still be in angle mode from the problems that we did previously. So when you put that into your calculator, you're going to end up with 80.3 because it wants us to round to one place. Okay, number 12. I'm going to draw this one down here because we don't really need that extra space, and this is a more complicated drawing. Okay, so we have and you all see what kind of artist I'm in here. There's the face, the stone face that's carved on the side of the mountain. Okay, we have the angle of elevation to the bottom of the face is 38 degrees, and to the top of the face, that is 41 degrees. We want to know the height of the stone face. So what I'm looking at is the blue triangle. This side is Y. Okay. This pink triangle here, I'll make zigzags around it so you can see it better since I've drawn them both in pink. That's X. Okay, and this part here is going to be found by doing Y minus X. Okay. So looking at our first triangle, the pink one, we're going to set up a ratio. The tangent of 38 equals, oh, and I forgot to name, this was 650 feet. Okay, so tangent of 38 equals x over 650. So x will be 650 tangent 38. Then the blue triangle, I'm going to say, move my calculator here so you can see. I'm going to say the tangent of 41 is equal to y over 650. So y will be 650 times the tangent of 41. We want to find y minus x to get the face. So I'm going to type in 650 tangent 41 minus 650 tangent 38. If I can move this over here, there we go. There we go. And so that tells me it's 57.20 because this one wanted us to round to 2 decimal places. Okay, then number 13, the angle is an integer when measured in radians. Give the radian measure of the angle. And we know that pi would be right here, and that's 3.14. So this here, okay, 14, when we're looking at the sine of 2 pi over 3. Remember, sine is y. Here's my unit circle. 2 pi over 3 is in quadrant 2, and so the y coordinate is radical 3 over 2. Okay, number 15, we are going to use the formula S equals R theta. So first of all, we're going to look at this large gear or large circle. When we look at our arc length there, we have 4.11 times pi. Okay, because my chain goes from here. Let me erase where I've outlined it in purple. From here to here. So that's going to be pi. Okay. Now we're going to set that equal to the small circle because that arc length is going to equal 1.07 theta, and we need to solve for theta there. Okay, so on my calculator, that gives me 12.919 or 9119, so on. That's equal to 1.07 theta. So I'm going to divide by 1.07, and that gives me 12.06 for my theta. Now here, it tells me the bicycle wheel is 14.8 inches. So here, when I want to find my arc length, I'm going to say 14.8 times my theta that we found here, 12.06. And that gives me 178.6 inches. Okay, on number 16, this part is telling me that I'm looking in quadrant 2, and I want the angle that has a y over x of radical 3 over 3. Okay, so that part tells me quadrant 2, and then I'm solving for the angle. Tangent is y over x. So when I'm looking in quadrant 2, I have two options that have a radical 3 in it. I have 2 pi over 3, and I have 5 pi over 6. Okay. I'm going to need the 5 pi over 6 angle because when I use the 2 pi over 3, if I do y over x, my radical 3 is on the top, okay, with a 1 because the 2's would cancel. If I use 5 pi over 6, I have 1 on the top over radical 3, and rationalizing that out will give me the radical 3 over 3 that I need. So this is going to be 5 pi over 6. I don't think I can write that in that little box there. So there's your answer on that one. Okay, 17, when I'm just going to use this formula and substitute in what I have. My R is 8, and then 3 pi over 4. It wants an exact answer, so 4 goes into 8 twice. 2 times 3 is 6 pi. Okay, and then on 18, when you're finding the amplitude is going to be that number right there. So my amplitude is 5. Remember, it does always need to be positive because it's the absolute value. My period formula is 2 pi over b. My b value is right here, so 2 pi over 2 pi, which would give me 1. My period is 1. So it's going to make one wave from 0 to 1, and it's going to go up to 5. So B definitely doesn't go up to 5, so I can throw it out. Then, let's see, here's one wave, but sine usually goes up before it goes down, so I can cross that out. This one's going up before it goes down. So that looks like C would be it. Actually, they're not telling us the period there, though, are they? But this one is telling us 2, so that would have to be 1. So actually, D is going to be our answer. Those two are very, very similar, aren't they? If it wasn't for the scale thing. I'm trying to see if maybe my copy didn't work out well and if that's actually a 1 there at the end. But regardless, this is definitely a 2. So D is our answer there. Okay, I think that's a good stopping point. We'll pick up with the rest of, or some more of the review on the next video.